All right, welcome back. Mic check looks good. So we're gonna keep working on the self-managed network. So this is a modular home network that can be accessed anywhere in the world through a VPN. And within this home network, we have a number of things. We have an ad blocker running at the firewall. So that means if I'm anywhere in the world, Japan, Germany, South Africa, all I need to do is enable my VPN and I can browse the web ad free. The other thing that I can do with my VPN is access services that I'm running on my local area network. And one of those services could be an alternative to um, things like the OpenAI API platform. So if we take a look at the pricing, we can see that you can access their models uh, through an API call for a certain price. And it's not just open AI that has these offerings, a low latency multimodal experience using speech to speech. All these offerings are available through a number of providers. Hugging Face also has their own API that they service that they call inference endpoints, where you can go through and access those. So this is what I'm going to do on my local area network is I'm going to set this up to run for free. So, it's going to cost electricity, it's going to cost the parts, but I don't have to worry about running out of usage time. I don't have to worry about accidentally running up a bill that I can't afford, which is my biggest concern with all this. And then, most importantly, all the data belongs to me. It's going to be very, very hard for someone else to access my data, which would be really important if, let's say, you're traveling. Like I went to an event this weekend. Um, where uh, it was a kind of a event where a Burning Man style event, and if anyone's familiar with Burning Man, they know that any pictures or anything like that is completely forbidden. This event, as far as I understood, didn't have the same kind of restrictions, but basically I can essentially follow those restrictions because all the pictures and video are completely private. They're not gone through and I don't have to trust a company to keep my data private. It's all my own in my living space on my drives. And in the guide by Lewis Rossman, there were some uh, examples of a of consequences that could happen if you're not careful to keep your data private and belonging to you. The most notable example was a father was concerned about his kid's health. Took a picture of his kid. The picture contained nudity of his kid, sent it to his doctor, and he became investigated for committing a crime. So it's not this is the idea of this isn't to enable you to commit crimes. If your goal with this is to commit crimes, um, uh, you know, change your life. You don't need to commit crimes to have a good life. You can get help for what ails you that is kind of forcing your hand into wanting to commit a crime. So don't get me wrong with all this. None of this is with the intent to commit a crime. Crime is crime, whether it happens on a computer or not. So, but it can protect you from having a crime committed against you, such as your freedom of expression, or theft of your data. For me specifically, my why, my goal with this is I'm a little bit of a like an artist. I created a some art on my YouTube channel. I obviously create these videos. I play music, so I want my things that I produce to belong to me. And if I so choose to share them with the world, I want to do that with evidence and proof that I'm the one who created it. As it is now, just uploading things to YouTube like this, YouTube could say, "Yeah, you uploaded it, but it's mine now. Like you gave it to me, and in fact, you never created it." In the age of AI, where things become so convincing, it could be very easy for them to just say, "Oh, well, this is just the result of our AI. You didn't even create this at all." And if, the data belongs to me and it's on my personal gear, I can say, "Well, look, here's a drive I have, and we can see the timestamps, and we can see, I couldn't use AI to have created this. I created this 10 years ago. It's here on this drive, so this is proof that I made it." And if things ever get that crazy, who knows how effective that could be, like in a court or something like that. That's where you'd probably end up if there were big disputes like that. But it's not just about that sort of stuff too. It's useful to have a robust and modular home network because you can just do simple things like um, having storage space. You have more storage space on your network. You don't have to, futz around with running out of space on your disk or whatever. Or if you run out of space, it's just as easy as just slotting in an extra disk, really easy. So it's just easier to use computing services at home if you if you go through this guide here. All right, so where I left off in the guide was booting from the USB drive. So I need to make a determination of which of my towers that I got for free from friends and neighbors. This is what, and there's no distinction from the two, but this is what I advocate people do following this guide, because you're going to cut down your costs. If we go to, for example, Craigslist, and we look at a desktop tower, we can see, like, even just for something like this, an Optiplex, $60. Um, it's this old thing here, $120. So if you've got a neighbor or someone that just has these laying around cluttered in their closet that they just want to get rid of, you can save potentially up to $120 just by taking this thing, gutting out the 10, 20-year-old insides that don't work anymore, and repurposing that case. Now, there is a caveat there. Motherboards are designed to fit in specific cases, so you might be limited in which motherboards you can use. So you do have to be a little bit discriminating with this so that your motherboard actually fits in. But if you can get it for free, it can definitely end up being worth it in the end. In fact, there's whole businesses based around the idea of collecting junk and recycling it. There's computer recycling businesses, there's data recovery businesses that collect old junk. So it can definitely, if you're doing this kind of stuff actively day to day, for example, like I am for a YouTube channel, it definitely makes sense. I do have to give the caveat, though, that you might end up with a lot of old equipment laying around. So you do need a place to store it. You do need, it could end up being more trouble than it's worth for sure. All right, so that brings me to where I left off in the guide, which was booting from the USB drive. So last video, I created the USB drive I'm going to boot to. So I will take that out now that it's created, and I didn't safely remove the drive. I'm not sure what that even does. Let me ask ChatGPT about that. I'm interested. Hey, so I didn't safely remove my USB drive. What does that mean? Like I don't understand. Like, should I have done that?
Hey, it's a good idea to safely remove a USB drive because it ensures all data is written and no files are in use. If you just pull it out, you might risk corrupting files or losing data. Most times it's fine, but it's best to do it the safe way.
All right, well, whatever. It sounds like it would be fine.
Yeah, chances are it'll be fine this time. Just something to keep in mind for the future.
All right, so there you have it. If you don't safely remove your drive, you could end up with your drive not working and you can burn up time. So in this case, it definitely would have made a lot of sense to safely remove my drive. To do that, all you got to do is click down here somewhere and do that. Um, so if something goes wrong with this process, it could be because I didn't safely remove my drive and there's corrupted data on the drive. Okay, so next step, I will enable my camera for. I'm going to take a look at both of these towers that I have, and I'm going to make a selection between one or the other. So I'm going to clear off a space to show these towers, bring in a camera light, and then take a video of the towers. All right, and that'll take me a little bit of time to do. I have to rearrange things and unplug the light and bring it into the other room. All right, and then I will likely have to adjust the height of the light as well. Oops, and the light is not in a state where it can be safely moved about the apartment, so I'll fix that. All right, so now all I gotta do is plug in this light and then lug over the towers. Okay, so this should be a good. This should work. Ugh. Towers are quite heavy. Ugh. 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 Okay, so yep, there we go. So let's get a good shot here. Oh, and I've got to unpause my. There we go. So now you should see the shot I have. which should be a pretty good shot. So I've got the two towers here. Both of them I got completely free. So definitely that is the way to go. So let me set up a shot here if I'm able to. So I just need something to prop this up. Uh, okay, there we go. Perfect. Oh, and that is sliding off, which makes things harder. Okay, move it back. Just move this whole thing back. Okay, but it's stuck against there, so I can't move it back. All right, so now I need something more reliable to prop it up with. Okay, so there we go. That's a better shot. And that should do it, hopefully. Yeah, there we go. So now I've got both of these here, and you should be able to see these pretty easily. So, um, and I'll be grabbing the camera and showing some more details. So here's the first one I have. Now we're going to set up a RAID. Um, so we're going to have to boot up um, these PCs, um, and we're going to have to so we're going to have to put in these two cards into the PC that we're going to use as the Ubuntu server. So the first thing we got to do is select which one of these we're going to use. This one here, which has a Ultimate Force Windows 8 ready motherboard. So if you want to upgrade from XP or Windows 7 to Windows 8, there you go. Here you go. That's your choice. That's a great choice for that. Um, then the other one we have is a uh, uh, Dell, and I can't see anything else about it. So um, this is an Asus and this is a Dell. So I don't know what the difference would be exactly. I wish I saw more information about this. Um, yeah, there's really nothing. I guess what I got is LS0911. I think that would let's try that. So I'm gonna go on my PC here. I'll mute this camera screen and let's look at a Dell LS and then type in the number. And then we'll use the word motherboard as well. All right, so it's an LS0911 and it's a motherboard. Okay, so I think this is probably what it is. It's a Precision T5600. I don't know though. It's you have to be careful to get it exactly right. So let's put this in quotes so that we're getting this exact number showing up there. And now this is a lot better. We've got um, yeah. So yeah, this I think it's safe to say that this is a T 5600. We can see that's uh, corresponds to it. Um, so yeah, let's go with this owner's manual. I think it's probably close enough. And before I do that, um, and I can unmute the camera, let me look for that that other identifier on there, which is a T5600. That might be printed on here somewhere. Um, T5600. Uh, Yeah, so it would be printed right on the motherboard itself. I don't see anything like that. I do see E93839. So let's try searching it again, and we'll search for E93839. Okay, so this actually looks quite a bit. Yeah, this looks quite a bit better. I think this is what it is. Is an E93839. Um, oh, so actually, it looks like from Dell.com, which is probably a very credible source. This E number is a UL number, so it's not a part number. A UL number, file number, identifies the manufacturer of a component. And actually, I can see. Okay, so does that say UL? I'm confused. No, it doesn't. Okay, so I don't see a symbol that says UL on the motherboard, but these take the form of E plus a number of digits, typically six. So we've got E, and then we've got, interesting, we've got five digits rather than six. So I guess I'm not exactly sure if that's a uh, this sort of number, but I, yeah. All right, so you know what? I think this is good because this looks exactly like what this is. So let's do a little bit of research on this, and we'll use ChatGPT and figure out which one is better to use. Hello, I have two workstations, so desktop towers that I got from friends and neighbors for free. I'm going to set up a Ubuntu server on my local area network, and it's going to provide API services for my own local language models running on my own hardware. So it won't be nearly as robust as the services I could otherwise purchase via OpenAI, Hugging Face, Perplexity, you name it. But it will be mine and mine alone. And on top of that, it will, I'll never run out of credits. I'll never have to worry about an extra charge. And on top of that, it'll be a perfect lab where I can break things that will. I'll learn how to set up this infrastructure and host the APIs myself, which would be a valuable employable skill. So I'm really happy about this project. I'm going to need your help with me though. I'm going to need you to help me with it though when you are ready to help.
That's a fantastic product, Graham. Setting up your own local API server to run language models on Ubuntu is an excellent way to build hands-on skills in infrastructure, networking, API management, and machine learning deployment, all highly employable skills. It's also a perfect sandbox for experimentation without worry of cost or credit limits. I'm fully ready to help you get started and make steady progress. Here's how we can break down your project into clear, achievable milestones. 1. Initial planning and requirements. Clearly define your goals for the server. Which local language models you plan to use, e.g., GPT models from Hugging Face, Llama, Mistral, etc. Estimating your hardware capabilities, CPU, RAM, GPU, for effective local deployment. 2. Setting up the Ubuntu server. Choose Ubuntu server version, typically Ubuntu 22.04 LTS for stability. Install and configure SSH for remote access. Secure the server, firewalls, user permissions, SSH keys. 3. Installing requirements.
All right, so we don't need to hear all that. It's done generating the output, so I'll continue prompting it. Okay, so I'm going to need your help with step number two, setting up the Ubuntu. Actually, sorry, no, I need your help with step number one, initial planning and requirements. Specifically, I need your help estimating my hardware capabilities for effective local deployment. Now, as I mentioned, I have two towers to choose from. One is an ASUS, the other one is a DELL. So the motherboards are quite different. I've narrowed down the DELL to be a Dell Precision Workstation T5600. I'm still not entirely sure what the ASUS is. It's got a motherboard on it that says that it's the Ultimate Force, that it's Windows 8 ready. It says CRYPHON to Z87. It says DGI plus power control. So it kind of looks like I would guess it to be an ATX motherboard, but this is what I need your help with. I need your help determining what kind of device that second tower is and which one I should use for my Ubuntu server. Okay, so there we go. That the where it said GRYPHAON and then it had a Z number. That was actually the name of the motherboard. So now we can get the official documentation for this actual motherboard. So the manual and document, there we go. So we have the user manual in French. We're going to need an English version. There we go. So now we've got the user manual for the English version. So now we've got the manuals for both of them, the Dell Precision Workstation and the Gryphon Z87. So let's plug in the manual. Okay, so great, thank you. I found the manual for each of these motherboards. When you are ready, I will give you the manuals. All right, so now I'll download each of the manuals. All right, and then add each of the manuals. So I'll upload from the computer. Okay, so I'm ready now. Please go ahead and share the manuals, and I'll help you carefully review them to determine precise capabilities, optimal setups, and any additional considerations for your Ubuntu server project. So I'm going to say, here are the manuals. All right, and then my next thing I would say, okay, so based on those manuals, which one should I choose for my Ubuntu server?
Based on careful examination of both manuals, here's a concise comparison and recommendation tailored specifically for your Ubuntu server and mobile AI language model deployment. Hardware comparison 1. Dell Precision T5600. Processor. Supports dual Intel Xeon E5-2600 series CPUs, providing excellent multi-thread performance ideal for running language models.
Nice.
RAM. Up to 128GB DDR3 ECC RAM, beneficial for memory-intensive tasks like language model inference. Expansion. Multiple PCIe slots available, suitable for adding GPUs or additional storage controllers. Storage. Flexible storage options with multiple drive bays. Reliability and durability. Workstation class reliability, well suited for continuous server operation. Key strengths. Dual CPU capability for heavy multitasking. Large RAM capacity, critical for ML models. Excellent expandability for future upgrades, GPUs, SSDs, etc. 2. ASUS Gryphon Z87. Processor. Single CPU support for Intel Core i7, i5, i3, 4th generation, suitable for lighter workloads. RAM. Up to 32GB DDR3 RAM, 90cc, limiting scalability for larger models. Expansion. Limited PCIe slots, micro ATX form factor. Storage. Decent SATA options with fewer bays overall. Reliability and durability. Solid construction for standard desktop usage. Key strengths. Good for basic to moderate workloads. Compact size ideal for limited physical space. Recommended choice. Dell Precision T5600. Reasons. Scalability. Significantly better RAM capacity and CPU processing power, critical for global language model inference. Flexibility, more upgrade options, RAM, GPS, and storage expansions. Performance, dual Xeon CPUs offer superior performance for computationally intensive tasks. Given your goal of running mobile language models and APIs, the Dell Precision T5600 clearly offers superior performance and flexibility compared to the Asus Griffin Z87-based system. Next steps, inventory check, confirm installed RAM, CPU configuration.
All right, so we don't need to hear any more about that. The decision is clear. We're going to go with the Precision T5600. So we'll probably use the other one for something else later down the line, perhaps. But for now, we're going with this one here. So I'm going to enable the camera again, and then I'll take the Asus and put it off in my storage location. Now, one of the things I didn't like about this Dell Precision is I found it very hard to put the case back on, but I was trying to slide the case over like this, and I think to put it on, you have to slide it down like that. Um, but yeah, so that's how you put it on. Instead of sliding it over like that, you slide it down like this, and then it sits up. So it sits so that it fits in on the bottom, but it doesn't fit in on the top. So all you have to do is lift this up, and then it drops down on the top. It's snug on the bottom. Let go, and now it's in perfect. So that was the issue. I was sliding over to the right rather than sliding straight down, lifting the handle to have it drop into place, and then releasing the handle. So this will be a perfect device for my Ubuntu server. And this device might be good for something else. It's a pretty it's definitely a very old device, which would be great for specific applications. In fact, let's go to ChatGPT and let's see what I could use that for before I put it away. So I'll have to open it again. I closed it. Oh, and something's going. Okay, there we go. All right, so now tell me this. So the answer is clear, right? I should definitely go with the Precision T5600. So now give me some ideas for what I could use that ASUS for. All right, so here we go. So I would have liked to have it read it out loud to me, but once it's done generating, that should be possible. So let's just wait for it to finish generating and then have it read while I'm putting the other one away in my storage corner. All right, so it's got a lot of ideas. So far, it has 8 different ideas, and these all look like good ideas. This idea here, a retro gaming server or arcade similar, is a great idea. There's some amazing games that are super old. One is Marvel versus Capcom 2. Um, like you can run that on just about anything, and it's it's a very fun game. So you can just basically go back and play all of the best games ever created um, decades ago on this thing. And you can do that without cluttering up your environment that you're doing serious work on, which can be nice. All right, so let's have it read that out loud for me while I'm putting this away.
Absolutely. Repurposing the Absolutely. Repurposing the ASUS Greph Z87 system is a fantastic idea, especially since you have it handy. Here are several practical, engaging, and beneficial uses. Nash 1. 1. Home media server, Plex Jellyfin MB. Host your own streaming media library for movies, TV shows, and music. Easily accessible across multiple devices in your home. Why? Stable, quiet performance ideal for media streaming. Set up Ubuntu or Debian, Plex Media Server, or Jellyfin. Install extra storage, e.g. larger HDD SSD. 2. Network Storage Solution NAS. Centralized backup storage for all your devices, can provide automatic backup and syncing. Why? ASUS board provides sufficient SATA ports for multiple drives. Setup, Open Media Vault or TrueNAS Core, RAID configuration for redundancy, remote access setup via VPN or SSH. 3. Dedicated firewall router, pfSense or OPNsense, improved home network security, robust firewall, VPN gateway, and traffic management. Why? Ideal hardware specs to manage your home network effectively. Setup, pfSense or OPNsense OS, additional NISI card optional, inexpensive, VPN integration for secure remote access. 4. Surveillance camera server. Run software like ZoneMinder or Shinobi to monitor security cameras. Locally record and manage your video surveillance. Why? Solid performance, easily handles multiple camera streams. Setup, Ubuntu server, ZoneMinder, cameras connected via network, PoE IP cameras, accessible remotely over VPN. 5. Continuous integration, CI/CD and development server. Host personal Git repositories, Gitfia or GitLab. Run automated build and test systems, Jenkins, GitLab CI. Why? Good fit for software development, testing, and experimenting. Setup, Ubuntu server, Docker, Jenkins, GitLab. 6. Virtualization lab. Explore virtualization technologies, Proxmox, VMware, KVM. Test different operating systems and network setup safely. Why? Great educational value for advancing IT skills. Setup, Proxmox VE or VMware ESXi. Experiment with VMs for software tests or infrastructure simulation. 7. Home automation server, Home Assistant, centralized smart home device management, automate lights, sensors, climate control, and more. Why? Reliable, low noise, ideal for always-on smart home management. Setup, Ubuntu Debian, Home Assistant, Docker, Zigbee, Z-Wave USB adapters. 8. Retro gaming server or arcade emulator. Create a retro gaming server for older arcade games and emulators. Connect via LAN to stream retro games to other devices. Why? Fun, nostalgic project with good performance. Set up Ubuntu plus RetroArch or Laka OS. Controller setup via USB or Bluetooth, HDMI out to TV or monitors. 9. Personal cloud server Nextcloud. Self-hosted alternative to Dropbox or Google Drive. File syncing, sharing, and secure data hosting. Why? Secure and private cloud storage, ideal for personal files and backups. Setup, Ubuntu server, Nextcloud, secure HTTPS DPS access via self-signed or Let's Encrypt certificates. 10. Educational and experimental lab. Dedicated environment for learning cybersecurity, penetration testing, or network engineering skills. Safe environment to break, fix, and learn systems and networks. Why? Ideal for your professional growth, network engineering, and development skills. Setup. Ubuntu server, Kali Linux VMs, or network simulation tools, GNS3, Docker environments for various testing scenarios, custom lab scenarios you design and control. Personal recommendation. Given your career goals, network engineering, programming, and general tech expertise, I'd highly recommend considering these as your top picks. Dedicated firewall router, pfSense, OPNsense for enhancing network skills. Virtualization lab, or educational and experimental lab to accelerate your hands-on experience. Let me know if one of these excites you, and we can dive deeper into setting it up.
All right, so there you have it. I already have the pfSense firewall. Yeah, so I could have set it up on this one and saved money for the Dell Optiplex, but I think I had already purchased the Dell Optiplex before I knew this was available. So this can be used for my virtualization lab or educational experimental lab, or not this one. This is my Dell. This is going to be a big deal, big Kahuna sort of thing. The other one's going to be kind of a rinky-dinky thing if I want to do something that is. I mean, it'd be great for a retro gaming. Like that would be really fun. That would be really really fun. Um, okay. So next, what I'm going to do is because it has the manual, I'm going to go into conversation mode, and ask it about the manual and ask it to help me hook these up. Okay, perfect. So thank you. You've been a huge help so far. I decided to go with my Dell server to turn it into my Ubuntu server. So the next step is I've got two SanDisk SSDs, and I need to plug them into the server. The SanDisk is a SATA. So I want you to help me plug it in. Now I see a number of connectors on here with different labels. One label is P12, SATA P12. I also see P13. I also see P10 and P11. So I want you to, based on the manual, tell me how to plug in both of these SATA drives. And if it's only possible to plug in one drive, I want you to tell me that based on what's in the manual.
Got it. The Dell Precision T5600 should have plenty of SATA ports available for your SSDs. Let's break down the steps for connecting them. 1. Identify SATA ports. The T5600 manual shows multiple SATA ports, typically labeled as SATA 0, SATA 1, etc. These are usually located on the motherboard in a cluster. 2. Plugging in the SSDs. First SSD. Connect the SATA data cable from the SSD to any available SATA port on the motherboard, e.g. SATA 0 or SATA 1. Second SSD. Connect the second SSD to another available SATA port, e.g. SATA 2 or SATA 3. 3. Power connection. Each SSD also needs a power connection from the power supply unit, PSU. Locate a spare SATA power connector from the PSU and plug it into the SSD. 4. BIOS check. After connecting the drives, power on a server and enter the BIOS, usually by pressing F2 or Del during boot. Verify that both SSDs are detected. You should be able to connect both SanDisk SSDs to the Dell Precision T5600 without issues. Let me know if you need further guidance on specific steps or troubleshooting.
Well, just briefly tell me, have you heard of that P numbering system? The P12, the P13. I've also got a P10 and a P11.
Yes, the P numbering system you see, e.g. P12, P13, typically refers to power connectors on the PSU, not SATA ports. These are used to supply power to drives and other peripherals. Each connector should match a corresponding power socket on your drives or other components. Make sure each SSD has both a data cable to a SATA port and a power connector from the PSU.
All right. Okay. Well, okay. So you said that those P numbers, because I've got more than that. I've got actually, it's quite confusing because I have two instances of P11, and these are on the connectors. So you said I need to be looking at the motherboard. Is that correct?
Yes, for connecting your SanDisk SSDs, you'll want to focus on the SATA ports on the motherboard, which are usually labeled SATA 0, SATA 1, etc. The P numbers on your power supply are for power connectors, not data. Here's a quick guide. 1. Identify SATA ports. Look for SATA ports on the motherboard and connect each SSD using a SATA data cable. 2. Power connectors. Use the P-numbered connectors from the PSU to provide power to the SSDs. Let me know if we need more details.
So like where specifically on the motherboard should I look? Because I'm kind of coming up short here. I don't see anything labeled SATA.
On the Dell Precision T5600 motherboard, the SATA ports are typically grouped together and located along the edge of the board. They might not be labeled as clearly as SATA, but often have small connectors with right angle slots. If you're having trouble locating them, 1. Check near the bottom right corner, SATA 4, of the motherboard when facing the front of the tower. 2. Look for small rectangular connectors, often color-coded, possibly white or black. 3. Refer to the manual diagram for the exact layout if you have it on hand. These ports will be where you connect your SATA data cables from the SSDs.
Okay, I think I found them. I see on the very bottom, I see SATA 1, SATA 0, and I see SATA 1. So it looks like this only has the capability of two SATAs, but it might have more because I also see the numbers HDD 0, HDD 1, all the way up to HDD 3, and I also see SAS 1. Have you ever heard of that? What does the manual say about that?
Yes, those labels indicate different types of connectors on the motherboard. Here's a quick breakdown based on typical Dell Precision workstations. SATA 0, SATA 1. These are standard SATA ports for connecting SSDs or HDDs. HDD 0, HDD 1, HDD 2, HDD 3. These typically refer to additional SATA ports dedicated for hard drives. You can use these for your SSDs as well. SAS 1. This is a serial attached SCSI port typically used for enterprise level SAS drives. It's not needed for your SATA SSDs. Based on this, you can connect your two SSDs to any available SATA port, whether it's labeled SATA or HDD. Just ensure you also connect the corresponding power connector from the PSU. Let me know if you need more help.
Okay, so this is a pretty awesome device for what I'm using it for, right? Because I can plug in up to six of these disks. That's pretty good, right?
Absolutely. Having up to 6 SATA ports gives you great flexibility for your Ubuntu server. You can add multiple SSDs for various purposes, like separate drives for the operating system, data storage, and backup. This setup is perfect for expanding storage, running virtual machines, or even setting up a RAID configuration for redundancy. It's definitely a solid choice for your project.
Yeah, that's what I'm working on now. I'm setting up RAID configuration.
Nice. Setting up a RAID configuration will give you both performance boosts and data redundancy, depending on the RAID level you choose. For example, RAID 1 mirrors your data for redundancy, while RAID 5 or 10 can balance redundancy and performance. Are you leaning toward a particular RAID level?
Yeah, I'm going to use RAID 0. I'm following a guide. The whole purpose of the guide is to kind of make this as easy as possible. So, like, an old grandmother could do it, which, I doubt the guide would accomplish that, but it certainly makes it so somebody like me is because the thing when doing projects like this is like so many people like try to do a project and like don't finish it and they just have junk laying around. Like, I want a real working project that I can actually show off and like be proud of.
That's a great approach, Graham. RAID 0 will give you excellent performance by striping data across both SSDs, maximizing speed. Just remember, it doesn't offer redundancy, so regular backups are key to protect your data. It's awesome you're committed to seeing the project through to completion. You'll definitely have something to be proud of once it's up and running.
Thanks. So now you might be familiar with this based on the manual. There's next to the right of the power supply, there's a black case and it has a screw on it. So I'm trying to remove that because it's kind of covering up that area of the motherboard where the drives will be plugged into. So can you help me remove that? Does the manual say anything about removing that? I unscrewed a screw, but I don't see what else to do.
Sure, the black case next to the power supply you're referring to is likely the air tunnel or shroud that helps with airflow. According to the T5600 manual, here's how to remove it. Unscrew the retention screw. You've already done this step. Great. There might be a retention tab or latch that needs to be raised or pressed down or outward. Look for a small tab near the base of the shroud. Once the tab is released, you should be able to lift or slide the shroud out gently. If you don't see a tab, it might require a bit of careful wiggling. If it's stubborn, double check for any hidden clips or additional screws. Let me know how it goes.
Okay, yeah, that's what I figured. There was a tab. I actually found the tab and I released the tab, and it came out really easily.
Awesome. I'm glad that worked smoothly. Now that you've got the shroud removed, you should have easy access to those SATA ports and can proceed with installing your SSDs. Let me know if there's anything else you need help with.
There's a lot of dust in here, so I'm just using a Dyson Z8 to get the dust out. Any tips for how to remove all the dust?
Using a Dyson V8 is a great idea. Here are some tips for removing dust safely. 1. Power off. Make sure the workstation is completely powered off and unplugged. 2. Anti-static precautions. Use an anti-stag wrist strap if possible and avoid touching components directly. Gentle suction. Use the vacuum on a low setting to avoid any strong suction that could damage components. Brush attachment. If available, use a soft brush attachment to gently dislodge dust from components. 5. Airflow. Ensure you blow or vacuum dust outwards, not deeper into the case. This should help get rid of all that dust.
Okay, so now tell me this. So in the SATA ports, there's going to be a let me think of the word. Oh yeah, so there's two connectors, right? Let's just start there. In a SATA drive, there's two like female connectors, correct?
Exactly. On a SATA drive, you'll find two connectors. One, SATA data connector. This is the smaller connector, typically used to connect a SATA data cable that links the drive to the motherboard. 2. SATA power connector, the wider connector, which provides power from the power supply unit, PSU. You'll need to connect both the data and power cables to each SSD for them to work properly.
Awesome, you read my mind. Yeah, I was gonna ask which one was which, the smaller one or the larger one.
Glad I could help. So just remember, the smaller connector is for data, and the larger one is for power. Once you connect both, you'll be all set to get your SSDs up and running.
All right, so I've got the data cable out. So now that the data cable is taken off the motherboard, I'm gonna slot it into the disk, and then I'll you know what? I might unslot it and then just kind of arrange it so that it's clean in there and held down in there. It looks like the case is actually designed to have things fit in a certain way, but I'm just gonna start by yanking out, harvesting things for parts and then kind of adding them back in as needed.
That sounds like a good plan. Keeping everything neat and organized will definitely help with airflow and future maintenance. Just take it step by step, and you'll have those drives installed in no time. If you need any guidance along the way, I'm here to help.
Okay, so then the next step would be to find a power connection from the power supply, clearly.
Exactly. Locate a spare SATA power connector from the power supply. It should be a flat, wide connector. Plug it into the SSD's power slot. If you need to rearrange cables for better cable management, now's a great time to do it. Once both the data and power cables are connected, you'll be set.
All right, I harvested two SATA data cables. So that's all I'm going to need for this project is just these two cables.
Perfect. With those two SATA data cables and the power connectors, you're all set to connect both SSDs. Once everything is plugged in, you can move on to configuring them in your Ubuntu setup. Let me know if you need help with that step or anything else.
Well, I'm not quite all set. I still need the power connection.
Got it. For the power connection, locate the spare SATA power cables from your PSU. These connectors are typically bundled together. Once you've got them, plug them into the SSD's power ports. Then you'll be ready to roll.
Okay, and you think I should put that black cover back in that I took out, or do you think it's okay to leave off?
Reattaching the black shroud is generally a good idea, as it's designed to help with airflow and cooling. If the cables fit neatly with it in place, I'd recommend putting it back. It'll help keep dust out and ensure optimal cooling. If it's too tight, you can always adjust to the cables for a better fit.
Yeah, it's kind of annoying to get back on because it's like it like crowds those, it like pushes into the cables where they're connected, so I'd rather just leave it off.
If it's causing issues with cable crowding and everything's secure, it's fine to leave it off. Just ensure your airflow isn't significantly affected. Keeping an eye on temperatures once everything is up and running will help ensure your system stays cool.
Yeah, we'll be able to do that once Ubuntu is up and running, right?
Absolutely. Once Ubuntu is installed, you can monitor temperatures using tools like LM Sensors or pSensor. These will help you keep an eye on system temps and ensure everything's running smoothly. You'll be able to fine-tune your setup from there.
Okay, we'll have to do that. If there's issues with the temperature, then I can, like toggle a knob of like putting this part back in. But until we see an issue, I think it'll be fine.
Exactly. That sounds like a solid plan. You can always revisit the shroud if you notice any temperature spikes. But for now, it's all about getting everything up and running smoothly. Keep me posted if you need any more help along the way.
All right, so all I'm doing now is putting the case back on. Then I just plug this thing in to the wall, try to power it up, and then get a Ubuntu server running on it.
Sounds great. Once you've got the case back on and everything plugged in, you can start the Ubuntu installation. If you run into any hiccups during the install or need tips on partitioning, just let me know. Good luck.
All right, and there you have it. And we can see how powerful ChatGPT really is, even in its current iteration. And remember, it hasn't even increased a full one order of magnitude yet from when it was released. So it's going to increase by two full orders of magnitude around 2027. So imagine doing what I just did, but instead of something that any idiot working with computers should know, and I should have known, such as how to plug in a goddamn SATA connection that anyone should know. It's tells you how to build your own house. It tells you how to make musical instruments. It tells you how to make your own drugs. Like it tells you how to solve any problem in your life. You have problems with relationships. It tells you how psychology, how to do that, and it gives you a step-by-step clear guide, encouragement along the way. You know, the process I just did, this is happening right at the, you know, we've got the graph going exponentially up. This is happening at the bottom of the graph. So it taught me and gave me encouragement for just plugging in those SATA drives, which I really appreciated. But, you know, any idiot working with computers should know how to plug in a goddamn drive like that. Once I would ask him more sophisticated questions, it would probably break down. If I had it help me build a house, it probably wouldn't be so good at that. But you never know. It might be at this point. I don't know. And then the other thing is, it gave me a lot of really good recommendations. For example, whether I put that part back on or not is going to depend on my temperature readings. If I'm getting really bad temperature readings, my device is continually overheating. It would make sense to get that part back on because the case is designed for cooling it properly. So if it's not, if there are parts missing from the case, or not everything is in place as designed, it could affect the temperature of the case by making it worse. So we'll do power checks. We'll do checks like that on it. But for now, this will be it for sharing that. So I'm moving my filming light back to the other room. All right, and I'll definitely wash my hands after dealing with all that dust in there. Just some hand sanitizer should probably be fine. It's probably better to run some water over them. So I'll do both. I'll put on some hand sanitizer, run some water over my hands. Hand sanitizer, place the soap, dry them off, and I'll be good. All right, so there you have it. I selected the device to use. I plugged in my RAID drive. I harvested an extra SATA data cable that I can use for later, so that'll be really helpful. I don't have to go out and buy a cable if I can't find one. I just need to look in my storage area, and there'll be one there. So I'm going to put away my tools. All right, and now let's power this thing up and follow through with the rest of the guide. And I might cut the video here just because I'm happy with the progress I made so far in this video, and to logically put some more progress in another video would make a lot of sense. But let's go ahead and move to the next step, which is powering this thing up. I think it'll be fine to do it in this video, assuming I'll still recording. Let's check that. I do see a recording symbol, and I do see my audio is still running, so looks good. And I'm at the hour mark. That's typically in the past where I start to need a break. I found if I take like a 15-minute break, just put it on pause, I can come back and do another hour, and I can pretty easily do 3 hours if I do that. But I'm feeling good now, so let's just keep going. All right, so next thing would be to power this thing up. So obviously, the first step is to add a power cable. Now I could do this on camera. So yeah, let's do it on camera. All right, so here I am sitting here. Here I am with a power cable looking at the screen. Now I'm looking at the camera. Ugh. So now it says 635W. So let's go back with ChatGPT and make sure we don't damage it by using the wrong kind of cable. Hey, I'm back. I have another question for you. Now we're going to power up the device. So I see the connector for the power supply. It says 635W. I have I have a number of cables. I'm not sure which cable to use, so I'm hoping you can help me with that. Can I use any cable, or should I be looking for some specific attribute of the cable?
Welcome back. For connecting the power supply, you'll want to use the correct power cable that matches the PSU's output connectors. Typically, for a 635-watt PSU, you'll have cables labeled for PCIe, CPU, SATA, etc. To connect the PSU to your drives, you'll want the SATA power cables. These usually have a flat connector with a 15-pin layout. If your PSU has modular cables, look for the ones labeled SATA or with a similar marking. For the PSU to motherboard connection, ensure you use the main 24-pin ATX cable and the 8-pin CPU cable. These should be clearly labeled. If you're unsure about a specific cable, checking the PSU manual or looking for labels on the PSU itself can help confirm the right one. Let me know if you need more specifics.
Oh, I think you're confused there. I'm not talking about the cable from the to the drive, the SATA drive. I'm talking about the cable to the wall when I plug it into the wall.
Got it. You're referring to the power cable that connects the PSU to the wall outlet. Typically, any standard power cable that matches the PSU's input socket will do the trick. If your PSU came with a cable, that's the safest bet. Just ensure it's in good condition and you're set.
Okay, that's good to know. Anyone will do. Should I plug it directly into the wall, or am I fine plugging it into like a power strip?
It's generally fine to use a power strip, especially if it has surge protection. Just make sure the strip can handle the PSU's wattage. If your setup is near a stable, grounded outlet, plugging directly into the wall is also a great option. Either way, you're good to go.
All right, I'm good to go. Thank you.
You're welcome. Glad to hear you're all set. If you have any more questions as you continue with your project, just let me know. Good luck powering up your system.
All right, so I definitely overcomplicated that in my mind. All I got to do is plug this in to my power cable here. Then I do need an external drive. The other thing I need to be very mindful of is the beep codes. If I see that it starts beeping, or if I see, because remember the Optiplex, right? It had special codes on it through the blinks on it. So I should check the blinking as well. So let me undo this and put this up by the camera. And hopefully this is visible. It's probably just barely visible, but we can see 1, 2, 3 in amber is listed on there. So we're going to need to go back to the AI and have a discussion about what this 1, 2, 3 in amber means. So let's do that. All right, I'm back. I actually need your knowledge of the manual again. So I'm booting it up and I want to make sure that it's booting up properly. So I'm looking at I'm listening for beep codes, didn't hear a beep. So now I'm looking at the lights on the front and I see 1, 2, and 3. There are three lights, each display the numbers 1, 2, and 3. And I see that they are all displayed in amber now.
All right, amber diagnostic lights can indicate specific issues depending on the pattern. In the Dell Precision T5600, the exact combination of lights tells us more. Let's break it down. Light 1, 2, and 3, this combination generally signals looks like a hardware failure. To get more specifics, refer to the manual's diagnostic section. Troubleshooting steps. 1. Check connections. Ensure all internal components, RAM, GPUs, drives, are seated properly. 2. Remove and reinstall RAM. Try booting with just one RAM stick at a time. 3. Disconnect peripherals. Remove any non-essential peripherals and try again. If it's still showing amber lights, the next step would be to check the manual for specific error codes or contact support. Let me know if you need more details.
Well, if there's no boot partition, do you think I would get that?
If there's no boot partition or the system can't find a bootable device, you'd typically see an error message on the screen rather than specific AMBO diagnostic lights. The amber lights usually indicate a hardware issue. If you aren't seeing any on-screen error messages, it's best to check connections, RAM, or potentially the GPU. If there's no display at all, it could be related to those components. Checking the manual for specific patterns will help narrow it down.
Ah, so that's kind of not good to hear. So it sounds like I might have to open the case to diagnose this.
It might be necessary to open the case and double-check connections and components. Sometimes, reseating RAM or ensuring the GPU is firmly in place can resolve the issue. Take your time, and if you need any guidance, I'm here to help.
All right, but I'm gonna plug in my peripherals now, because I have a bootable drive, so I'm just gonna plug in everything I need to get this up and running, and then I'll be able to easily unplug it if I need to go into the case. But I kind of, it's probably just a waste of time, but I want to see what happens if I have all my peripherals plugged in, just kind of for my own sanity's sake, even though I know it's probably not going to make a difference.
I understand the curiosity. It's always satisfying to see what happens when everything is connected. Go ahead and plug in your peripherals. If it doesn't boot properly, you'll know to check inside the case. Either way, you'll get some valuable information about what's going on. Let me know what happens.
Okay, so yeah, so next I just need an HDMI cable, which I believe I have to get that monitor plugged in, and then we'll see what happens.
Great! Once you've got the HDMI cable connected to your monitor, you'll be able to see what's happening during boot. This will give you a clear indication of any error messages or where the boot process is getting stuck. Fingers crossed for a smooth startup.
I mean, most likely what's going to happen is I'll just get that same Amber code, and I'll have to troubleshoot from there, but we'll see.
Yeah, it's always possible, but at least you'll know for sure what you're dealing with and can move forward from there. Troubleshooting step by step is the way to go. Good luck, and if you hit any snags, I'm here to help.
Well, the first snag I'm hitting is I don't know where my HDMI cables are. I know I have a bunch of them, but I don't know where I put them.
That can be frustrating. Maybe check around areas where you usually store cables or behind your TV or desk. HDMI cables often end up in those spots. If you can't find one, maybe a friend or neighbor has a spare. Good luck on the hunt.
You know what I can do? I know where I have one HDMI cable. It's kind of annoying because I'm trying to use it, but like despite my efforts for trying to use it, it's not working. So I can just use that one because it's not working anyway.
That's a practical solution. Using the non-working HDMI cable for now will at least let you see what's going on with the boot. Once everything's sorted, you can always replace it. Let's see what happens when you power up.
Yeah, and to be clear, like the cable itself is working. It's just like it's off a card, it's off a monitor, so I'm pretty sure the cable does work. So I think it'll be fine to use. Like obviously, if the cable itself weren't working, then this wouldn't work. Uh-oh, and it looks like I've got another snag. It looks like there's no. There's no HDMI ports on this thing at all, so I actually have to use a different cable. Oh, are you there? Hello? All right, so that happens sometimes with ChatGPT. No big deal. It just kind of drops. Um, so th- I'm gonna have to use a VGA cable, which because this doesn't have anything but that. So I think I have a VGA cable. I'm just not sure where. Oh, right here. I see it right here. All right, so here's my VGA cable. So just plug it in like this, twist in the screws to secure it in place. All right, and now I can set up my monitor and do a sanity check. Oops, but that's interesting. That's out, not in. Uh, hmm. Well, I definitely need to get a external monitor on this thing. Not sure how to do that. Another thing I could do is I think a console cable might work. Um, yeah, so let's try that. Let's use a console cable. I know I have one of those as well. I just don't know where it is. Here's my bootable drive, so I'll put that in. Okay, and then console cable is going to be really important, which I know I have. I just don't know where I have it. Ah, here we go. This is even better. I have a cable that converts VGA to HDMI. All right, and this uses VGA, so all I gotta do is plug in the cable. Verify that these connectors are the same, and we can see that they're actually quite a bit different. So I'm actually not sure what this card is. It looks like yeah, it's not gonna work with this cable. Um, so I think console is my best bet. I'm not sure what kind of card that is there, but it looks like it's not the card I need. So yeah, so console it is. All right, so I keep my console cables in this little case here. Not sure if my camera's running. Let's check. Okay, yeah, my camera's running and I still have a good shot. So this is where I keep my console cables. I've actually got two console cables to choose from. One is console to USB, and then the other is um, uh, yeah, the other is console to. You know what? This one might work. This one might work. Um, yeah, because then I just open up Putty, and I could, yeah, but I have to create a COM port. If it's not a COM port, it's not gonna work. Let me see what I got. Okay, I can see the other one. Uh, that'll work, but it'll take down my internet, which is fine because I have a backup over Wi-Fi. But that's an internet port, not a console port. All right, I think the best way to go um, is we're going to use this cable that has the USB. We're going to plug in the connection to the console port, and I can show that um, if I flip this around. This will make everything clear. So here's a card of some kind. I don't know what kind of card this is. I guess I just kind of assumed this was a graphics card, but the connector here isn't working with my. There's no HDMI. There's no VGA. So this is some kind of card that I'm not sure what kind of card this is. So this card isn't going to work. The key thing is we have a console port here. So I should be able to get in that way using Putty. All right, so whoop, wrong side. So we got to plug in the this side of the console cable. Oh, which is a okay, huh? All right, well this is a male side. Okay, so unfortunately this is designed to go um, for this end to go into the serial port, and this side to go out the other way. So that's not going to work. Um, yeah. So this side is what is the side that goes into the laptop. So we'd be using this as the console server, and then another device has a device to console into. So that's the opposite of what we want. We want to console into this device from a console server. So this port here doesn't enable us to do that. It enables us to do the opposite of that. So okay, so I think we can do it this way. Um, we can take this side. And this would be a good discussion to have ChatGPT on board with. But for now, let's just try this. So we're going to plug in this to this side, and then plug in this to the console server on my to the console port, which it doesn't have. Let's see what it has. All right, no, it doesn't have that. Okay, interesting. Let's pull up ChatGPT and get some help. And I can use a new, let's use a new chat and load it up with the manual. All right, so here's a new chat. I'm going to, oops, and I'm going to share my screen.
So now I'm going to upload from the computer the manual for there. And then I'm going to say, here is the manual to a device I'm setting up to be an Ubuntu server. Please read the manual, and then let me know if you find a section on counseling into the server, because I think I need to do that. All right, and we'll read the manual along with the AI.
I reviewed the Dell Precision T5600 owner's manual carefully. This manual covers hardware procedures, setup, troubleshooting, and technical specifications in detail, but it does not include any section specifically related to connecting counseling into the server or remote access instructions. For remote access, such as SSH or remote management, you'll typically need to configure your Ubuntu server installation directly. Set up networking and SSH from the operating system, Ubuntu, rather than through Dell's hardware manual.
All right, well then forget about console access. What I'm really asking is I need to get a monitor up on this thing so that I can like do things in the BIOS, you know? So like how do I do that? Identify the video ports. Okay, so yeah, this is good. So um, on your server, you should find video ports on the back, depending on the graphics card installed. These ports typically include a display port, which is the most common, a DVI port, whatever that is. I've never heard of that. This could be what's on there. Or a VGA, less common. So I'm pretty sure it's a DVI. So let's Google for DVI and ignore whatever gross porn comes up. Looks like none of that came up, which is great. So DVI stands for Digital Video Interface. And let's take a look at the connector. All right, so the DVI, so it looks like this is a DVI here. It's got the line here. This is actually not a DVI. Whatever the heck this thing is, I don't want it. So let's get rid of it and let's slot in something more useful. All right, so I'm going to open the case. The power cable's unplugged. That's really important to make sure the power is unplugged whenever you're in the case. You could end up shocking yourself, or even worse, you could end up damaging the motherboard. So let's get rid of this card, whatever the heck this is. I don't even know what it is, but I don't think I need it for now. And you know what? It's kind of too much effort to get rid of it. So let's just keep it in and slot in a another card instead. There's no need to remove it. We'll just keep it in there, and then we'll add another card. All right, so I'm going to add this Asus graphics card here. So I'll share my screen here. So yeah, so here's my Asus graphics card. I'll add that in there. That'll give me lots of options. It gives me 2 DVI ports and 2 HDMI. It gives me 2 DVI ports, an HDMI port, and a display port. So not a lot of juice in this thing. You can't do a lot with when it comes to AI.
but you can definitely access your BIOS. You can definitely get things working on a monitor, and you can definitely do a lot with an old, emulators, old gaming system. So this is exactly what I need. Okay, so there's some kind of odd looking blue latches on this thing, so I'm gonna pop out all of the ones that I don't think I need on there. Then I'm going to kind of eyeball this to see how it would fit in. All right, so then I'll remove the metal piece there that is gonna be needed. And now this is an Asus. Hopefully this works on this motherboard. We might have compatibility issues there, but there we go. We have no issues with it slotting into space. So we've got now we've got it lining up perfectly here, so we can do this mechanism to do it in. We'll leave these other ones loose because then it'll be easier if I come back and install stuff later. And then this one had trouble getting out. I think I can figure out how to get it out now because you just have to do this mechanism thing here. But I'll leave it in. I don't know. It might boot up slower or something like that. If I'm kind of undecided. I feel like I don't need it, so let me take it out actually because I just don't want it to be. I like to keep things simple, so. It's just too complicated to have a component in there that I don't understand. So there we go. We're taking this component out, and now we can read all the information on it easier too, and really like figure out what this actually is. So I think it made a lot of sense to take it out, and then we don't have to just leave this in storage now too. We can actually put it in where that was. All right, and then just for this, because I don't want things to rattle around in here and to fall out, I am going to latch these all back out just because, and then I will take a look at this more closely to figure out like what this actually is. So it's definitely a video card. It's just kind of an unusual one. So we're better off with this GPU in here. And the other thing about having this in here is this will allow us to run some models directly from here. So we can run some very basic rudimentary models right from the Ubuntu server. And then the other cool thing is we can just it's a lot clearer what to do once we swap out once we swap this out. So if we want to upgrade this card, all we'll do is pull this card out and put in a new one here, and we can even better, we can just put in a second card without removing this. So this is the way to go for sure. All right, now the cover on, and remember the cover goes on down rather than over. Put the cover on. These can go down in there. Oh, and there's something blocking it from going on. Oh, I'm afraid it might be the big card. So that would be not so ideal. Okay, but the cover did go on. It's just kind of not on super tight. I think it's probably pushing up against the card, which might not be ideal for the longevity of the card, but it's on, so I'm happy with that. All right, so now it's easy because we have the card in there. So this goes on like that. Now I can use any port I want, anything I want. Let's use the DVI, just because it's right here on hand, real easy, ready to go. It's a very nice cable too. There we go. So now it plugs in nice and smooth. Yeah, so this is another good reason to harvest the old gear from your friends and neighbors, because they might give you these small, cables, stuff like that. Like we saw, you'll definitely get a SATA cable. You'll definitely get like a power cable. So it's kind of nice to have these things laying around sometimes. They, even though they have no value, you couldn't resell it. In fact, you could probably you probably have to pay to get it recycled or taken away. If you're an active IT professional, computer professional, while they're not, either because they're in some state of dormancy or because it's just an old computer and they never were, you can save yourself the hassle of having to, for a few pennies, go out to the store or order something and wait for something to arrive. All right, so next is this. All right, so now we can see this turned green here, so there's no issues with the power supply. Let's take a look at the status code. So we've got a green, sorry, we've got 1, 2, and 3 are in amber now, just like before. Aha, but now we've got, uh, so now we can see here, please power down and connect the PCIe power cables for this graphics card. So the graphics card doesn't have power. So let's do that. So we'll power it down just by unplugging it like that. We'll take this card out because it got bent up as I was moving around. So hopefully it'll still work. If it doesn't, I have another one. And then we'll leave the monitor plugged in, leave the keyboard plugged in. Take the case back off. All right, and now we can see very clearly. Here's the power cable, and sure enough, it hasn't been plugged in. So let's find a power cable that we can plug that in with. Okay, so we've got a number to we've got more than one to choose from here. This one's the easiest to break loose. Okay, so we're going to go with this power cable here, P10. And it looks like this is a female power cable. So it looks like it's not going to work with this. All right, so this is a great time for ChatGPT. I'm going to unplug I'm going to unplug this here. All right, and ChatGPT will definitely be able to help. Okay, so now this came out, so we can see exactly what this is now. It's a direct power, so that's interesting. So perhaps it was in the wrong slot. Perhaps I need to put this into. So yeah, I can see slots have something printed on it. So let's go to ChatGPT and get some help. And we'll use advanced voice mode for this. Hello, are you there?
Hey, yep, I'm here. What's up?
All right, so you have the manual for my server, right?
Exactly, I've got it. What do you need from it?
So I wasn't able to get into the BIOS because the graphics card that came with it was a very unusual card that I've never seen before. You could help me with that, but instead let's focus on putting in a different graphics card that I'm more familiar with. I have one here. So when you're ready, let's go over the details of what this one actually is, and let's try to get it working with this motherboard.
All right, let's do it. First, let's identify the graphics card you want to install. If you have the brand and model number handy, that'll help. Then we can check for compatibility, and I'll guide you through the installation process. Sound good?
Sounds good. So this is an ASUS, and it's a direct TCU number 2. And it also says on the back direct power, which I think is probably relevant.
Got it. So you have an Asus graphics card with direct CU cooling. Let's ensure it's compatible with your Precision T5600. The key things to check are the PCIe slot and power requirements. The T5600 supports PCIe 3.0, so your card should fit. Next, let's confirm the power supply. The T5600 has up to 825 watts, which should handle most GPUs. Do you know the power connectors required for your card?
Yeah, that's a good question. So I actually don't. I know that it has a PCIe slot it goes in, but I actually see another one. And when I slotted it in first, I actually did get it to display on my monitor. But what it said is that it needs it needs power in that other port. So I see that that other port has 8 female connectors, all clustered together.
All right, it sounds like your graphics card needs an 8-pin power connector. Most power supplies and workstations like the T5600 come with these connectors. Here's what to do. 1. Check the power supply. Open your workstation and look for a spare 8-pin connector. It's usually labeled PCIe and will fit right into the card's power port. 2. Connect it. Once you've found the 8-pin connector, plug it firmly into the card's power slot. Make sure it's secure. 3. Power up. Reassemble your workstation, connect your monitor, and power it on. The card should now get the power it needs. If you had any issues or specific questions along the way, let me know.
All right, I think I understand my issue now. So I the power supply, I definitely have an 8-pin port on that I can plug a cable into. But I think my issue is that the cable that's currently plugged into it is not the cable I need, because on the other side it has uh, uh, something that looks similar to the female end of the connector on the GPU, but there's only 6 instead of 8. And since they're female, I can't plug it into the GPU. So I think all I need to do is swap out the cable.
Exactly. Sounds like you've got a 6 plus 2 pin connector, which is pretty common. Here's what to do. 1. Check for a 6 plus 2 pin connector. The 6 plus 2 connector can be used as either a 6 pin or 8 pin. The extra 2 pins are usually separate, but attached to the main 6 pin part. 2. Combine and connect. If you see that extra 2-pin piece, align it with the 6-pin to form an 8-pin connector, and then plug it into your GPU's power slot. Secure everything. Once connected, ensure all cables are firmly in place. After that, power up the system. Your GPU should now have the power it needs.
All right, so I like what you said about there's an extra 2-pin. Did you say something about that?
Yes, exactly. Many power supply cables come with a 6+2-pin connector. The 6 and 2 pins are often attached together. If you see a smaller piece that can snap onto the 6-pin connector, combine them to form the full 8-pin connector needed for your GPU. Then, plug that into the graphics card. Let me know if you need help spotting it.
I think that's a negative. I should be fine though because right now I've got an 8 plus I've got a 6 plus 6 to an 8. So all I need is an 8 to an 8 and I should be off the ground. And I think my other throwaway PC probably has an 8 to 8 that I can harvest.
Got it. If you need an 8 to 8-pin cable, salvaging one from another PC is a solid plan. Once you have that cable, just swap it in, and your GPU should be good to go. Let me know how it goes, or if you need any more help.
All right, so there you have it. I can turn my this back on. And let me swing the camera over a little bit. All right, so now what I'm going to do is see if I got that 8 to 8 cable, because right now the cable I have that plugs into the connector on the motherboard is quite an odd cable. I've never really seen it before. On the other side, it has two female 6 connectors, so that's not going to work for this card. So. All right, and I opened the wrong side. All right, so there you have it. This is another great reason to get some old gear if you want to be a computer professional. Look at all these cables I have that I can harvest. So beautiful, beautiful cables. Even though this machine is Windows 8 ready, it does come with all of these cables that would otherwise be thrown in the trash, but that enable me to continue on with this project. So really, really good, good get here. All right, so now we can see we have got another one of these cables. See that this is the same cable. It's just a little bit less nice. It's not wrapped in this coil here, but we've now got 2 of these for my like on-hand inventory storage. All right, so just harvesting the cables. So this is a SATA data cable, so never have to buy a SATA data cable again because
the drive will probably either come with a cable or I'll have these extra ones. So let me just pull all these out. Another SATA data cable. The SATA data cables. So I've got all the SATA data cables in the world now, which might be handy later, especially as I scale up my capacity and add more drives. That'll be very useful. Now this is a SATA power cable, and it's connected directly to the power supply. So I can't harvest that cable because it belongs to the power supply. Oh, and I need to vacuum this out. Okay, there we go. So um, now I've got a loose screw in here. So let me see if I can put this somewhere. I don't know. Okay, so everything else is the power supply. Um, I'm tempted to take the power supply out. Um, hmm. Okay, so we do have the connectors that we need here. This 6+2 connector is what we need to provide power to the GPU. The problem is it's connected directly to the power supply, so we don't have that cable off of the power supply um, for the other one. So we basically we can't use this cable. Now we can probably try to swap out this power supply for that one, but now we're because this is a all-in-one made device. There's going to be compatibility issues. It's not going to fit inside the tower, so. Yeah, so unfortunately, therein lies the problem. We don't have a power supply capable of delivering power to this GPU. We have one here, but it's not going to fit in here. We might be able to swap out the motherboard in here, but it looks like the motherboard is too big for in here. If we take out all of these bays, these drive bays here, somehow we could probably fit the motherboard in. Um, but that would be essentially ruining the case, and I might want to use this later for something like a home arcade server or something like that. Or just another storage location, either for backup or for archival or something like that. All right, so I'm just thinking for a while, sitting here thinking. Um, yeah, so the card has to. I'll flip this over a little bit. So the card has to be uh, getting power directly from a power supply that's capable of delivering the power so that it goes into this connector here. And this power supply, I think, probably does have that. Yeah, so I can see it right here. In fact, it has two of those, it looks like. But it looks like they plug directly into the motherboard, so I'm not sure if that would work.
Yeah, so it definitely needs that power cable in there. But unfortunately, with this power supply, uh, we've got uh, we've got a problem. Now, what we might be able to do is use two power supplies. Let's ask the AI if that's a good idea or not. Yeah, so I'm just thinking right now. So the other really good idea is putting on back on that old graphics card and then using these. So these actually look like VGA ports. So if we can find a VGA cable, which I'm pretty sure I probably have, then we could just access it through VGA. So we would need a cable because this is the female side of the VGA. So we need a converter to convert the female to the male side, plug it in there, and then we're good to go. So if I have a VGA cable, that would be the easiest. Just slot back in that other card, and then we don't have to worry about the case not fitting over. Um, hmm. So yeah, let me go on a hunt for the VGA cable. And wouldn't you know it, we're in luck. I found a VGA cable with both male sides. So if you're a computer professional, um, save your cables. You know, come up with a storage system, put them in a closet, put them in your garage somewhere out of sight, out of mind until you need them. Because when you need them, you're really going to need them for home projects or what have you. So save your cables. All right, so now we can plug in this side to this side. All right, perfect. And now we can plug in the other side of this cable to this one. All right, perfect. Now we can use that other card. So we'll put this card back in my storage area and slot the other card back in. And we'll slot it back into this blue port. This is where it was to begin with, so I'll just put it back where it was. It's usually a decent strategy. So one thing that if you're watching this and you're a tech professional, you work at a shop or something, you might be kind of screaming your head off at me right now because I'm not using a anti-static strap. So I'd say definitely adhere to those best practices if you're doing this for like a customer or you're doing this for really expensive equipment that you bought and paid for yourself. An anti-static strap will cost you, you know, a few dollars, and it might legitimately prevent you from rendering your equipment useless. Um, I'm always an advocate of following best practices, but for me, it doesn't really make sense to do so because this gear I got for free, I didn't pay for. It'd be a shame to lose some free gear that I could actually put to use. But it wouldn't be a shame to, like, for example, ruin a customer's computer. So it's uh, it's definitely something I would advocate for doing, but unfortunately, I'm not going to be doing myself for this project because I don't have one. I don't want to delay the project for the time to get one. I feel like it would probably be fine for these components. I doubt it would cause significant damage. So we'll see. I could be proven wrong, but that's my reasoning for not using an anti-static strap. All right, and now the case actually fits on a lot better. So remember, it goes down instead of over. Now this cable will fit in. All right, and now we should have better results. Uh, Plugging this in, let's make sure that the drive is in. Um, all right, and then I'll make sure that I'm still sharing everything. Yep, I'm sharing everything. Everything looks good. We're at the 2 hour mark now, but I'm kind of on a roll, so we'll keep running. I was in the dust and all that, so I'm going to wipe off my hands a little. All right, and now let's power this thing up and see what we got. Okay, so we've got a green on the power supply. That's always a good sign. That means you're getting power to the device. You don't get a green there, you're dead in the water. Now we've got a number 3 in amber, and we've got a blinking number 4. Now we've got the 1 and the 3 up. Uh, sorry, it would be a. Oh, interesting. Huh. No, we don't have a 4. We only have a 1, 2, and 3. So the 1, 2, and 3 turn themselves off. I'm not sure what happened there. Um, yeah, so now the 1, 2, and 3 are no longer in amber, which is probably good. They did turn themselves off though, which is definitely bad. We want to see like something like green or white showing up. Now on my monitor, we can see my monitor is turned on, ready to receive a signal. So it's not receiving any sort of signal. So I'll just verify the connections here. And I can get rid of this other HDMI connection. It's not necessary. All right, so nothing's happening now. So let's try the kind of easy answer that I guarantee will be wrong. It's just a waste of time, but it's good for sanity. Sometimes it's nice to just like, feel like you're sane. So I'm gonna put this in here, see if that makes a difference. Yeah, I didn't think that would make a difference. I'll try turning this off and on again. Yeah, so I think we're going to need to see some sort of indicator on the front panel that is like green or white. So let's go back to ChatGPT and talk about the manual some more, and we'll put it side by side. In fact, let's just skip ChatGPT. I don't think it matters. We'll just go right to the manual and we'll look right at the LED codes. So I'll share my screen and we don't even need ChatGPT to help. So we got the boot sequence here. We've got diagnostics. Here we go. So diagnostic LEDs. This is what we need on page 50. So I'll show the diagnostic LED that I was seeing. It looks like we do have 4 of them. So I was seeing 1, 2, and 3 lit up. They were lit up in amber, not green. But I think some other failure has occurred is probably accurate. It's probably what that means. So ensure that the display monitor is plugged into a discrete graphic card. I don't know what that means. I don't know what the word discrete means there. Ensure that all hard drives and optical drive bays are properly connected to the system motherboard. If there's an error message on the screen identifying a problem with the device, such as the floppy drive or hard drive, check the device to make sure it is functioning properly. If the operating system is attempting to boot from a device such as a floppy drive or optical drive, check setup to ensure the boot sequence is correct for the devices. Okay, so all right, now we can use the power button, I think. So let's hit the power button and turn it off that way. There we go. And then power it on using the power button, because I think those status codes might, and then just keep an eye on the status codes. So we've got status code 3 and 4 now, which should be in the manual. Yep, so here's the manual. Now we've got 3 only, and then it went to 1 and 2. Okay, and then it moved on from 1 and 2 to 1, 2, and 3. Okay, and then that went away, and now there's nothing displayed. So let's see. Yeah, so here we go. So there's nothing displayed. So the computer is either turned off or is not receiving power. Aha! So there we go. The computer is booted and operating normally. So a round of applause for me. The computer is booted and operating normally. So next we got to get get it booting up. Yeah, getting it booting up to this drive. So we need to get inside the BIOS. Okay, and then the other thing, okay, so we still don't know if this setup works with this graphics card. We did see a message on this screen, and I'll switch over to the camera. We did see a message on the screen, but that message was displayed using the other graphics card, so we still don't know if this setup is going to work here. All right, so I'm just sitting and thinking for a bit. I might need to talk to ChatGPT some more. There's a little bit of bad news. It is, yeah, it is quite a bit of a noisy machine, which is kind of bad news. But it should be fine off in the corner. My other machine is completely silent. It's just white noise, like fans. It should be okay. That's why this stuff is off in a closet somewhere, because it can be noisy with the fans. You don't have the fans on, it's going to overheat. Okay, so obviously there's something going wrong with this display, this port here. So let's power it down, which we can use using the button now. Okay, and then unplug the cable, and let's take a look if the graphics card needed power. That's what I'm guessing. The same thing happened as with the other one. It needed some kind of power connection that it doesn't have. All right, and this is kind of a lesson learned. Before you mess around with a motherboard, it makes sense to take pictures of the motherboard as you go. Otherwise, you're going to forget, oh, was there a cable connected to this that I took off? I don't remember. If you go back and look at the picture, then you won't need to rely on your very faulty memory. Okay, but I don't see any obviously loose cords around here, and my faulty memory is telling me that there was nothing in here. So yeah, and it looks like this plugs into this fan here, so it looks like this is another power supply for a more robust fan that would take more power or something like that. It looks like it's not, it doesn't have to do with the card working at all. So. All right, so let me slot that back in. Ah, That could be the problem, is it wasn't slotted in all the way. I actually had to apply quite a bit of force to get it in there, and I think last time I didn't push it in all the way. So sometimes, as careful as you want to be with some of these things, sometimes you really do have to give them quite the push to get them in. You should never have to, like, put your whole body into it. You should be able to use your fingers. You shouldn't have to take out a tool and wrench it in. You definitely can damage cards like this if you just shove them in there, but sometimes it takes a little bit more pressure than you would like to give it. Sometimes you hope that it'll just snap into place, but when push comes to shove, you have to really push it in for it to actually snap in. Oh, and there goes my camera. But the good news is we're kind of done here. So I can there's my leg. So let me mute the camera here and plug it in, and I'll just kind of come in as needed. Now the thing is, we would have gotten a code if that were the case, an LED code. So I don't think that was the case. So you can see my setup here. We've got the monitor up. We've got no power. So that's the first thing we got to troubleshoot is why didn't that power up where it powered up before? All right, so I hit the power button. Now we got power. So this is good that it's up like that too, because now we can take a look at the code. So we've got a 3 and we've got a 4 blinking. But as long as these turn off and we've got no codes displaying, no numbers displaying, things are good to go. But we do have a 3 that's on there for quite a bit. We've got a 4 that's on there for quite a bit. Now, I think according to the manual, because the manual shows these in green, and right now they're in yellow, I think we don't have a real problem that's indicated by the numbers there, unless the numbers turn to green. So I think this is just the power on self-test, where it's testing these certain things. And if there was an actual issue, then they would turn to green. All right, and now we see a better result with the monitor. It's turning white, which is a good sign. Yeah, it turned white twice, and then it turned itself off, so that's a good sign. I can also use a different monitor. So I think that's the next thing to try, is to just try a different monitor. But we can see it's continually turning white and then back to black. So it does appear to be getting a signal of some kind. So the next step would be to just simply take the monitor and replace it for one that doesn't turn white like that. Because this is just a junk monitor that sits in a pile, so it might not even work anymore. All right, so I'm going to take the camera out. All right, and now that we're this far, I can clean up the other the Asus here. These extra cables that I harvested, I'll put in a cardboard box out of the way. All right, and I lost one of the screws, unfortunately. I don't know if I ever had it in the first place. Maybe not. Again, this is why it's important to take pictures as you go, because then you can tell, oh, I did have the screw, but it's just not here right now, or what have you. So definitely um, something I can improve upon next time. All right, I'll just dump the screw in there. All right, hopefully the other screw turns up. Until then, this belongs in storage. All right, and the monitor does appear to be getting a signal, which is good news. Unfortunately, that signal is just being interpreted as a pure white screen. So the next step is to try a different monitor, I think. Ugh. All right, that monitor won't work. Actually, that monitor would work great for console. All right, so yeah, that there's something off with the graphics card or the monitor. So I'm just going to go in through console. All right, and now I can share my um, camera and see what I got going here. All right, so here's my camera again. We can see I've got this here, which is getting a signal from the graphics card, but unfortunately that signal is just resulting in a white screen. I've got another monitor here, which unfortunately doesn't have a VGA connection, but I have this console connection here going into that monitor. So it does have a connection for that. I think it could be for something else, but hopefully that works. All right, so nothing yet. Turning the monitor on, off and back on again, just for sanity's sake, even though I know it don't work, which probably means I'm more insane. Yeah, so no connection, check signal cable. So yeah, and this monitor doesn't have the ability to do VGA, so we're gonna have to find yet another monitor still. All right, so I'm looking at another monitor. No VGA on this monitor either. No VGA anywhere. All right, well, this might be a problem. Oh, I got another monitor over here. And yeah, of course, this monitor definitely would not have VGA. All right, so that's all I got. I'm not kind of not sure what to do because I need that. Uh, I need it to be working, um, and it's not. I feel like I've tried everything. Um, I mean, the good news is getting that white signal, I think, is a sign of things uh, very nearly working. So if I can just figure out how to go from that white signal to an actual signal. Okay, so yeah, huh. Yeah, so when I unplug the monitor, uh, it loses that white signal. So I'm very close. We just need to get a real signal rather than just that white signal, and we'll be good to go. None of the diagnostic LEDs are on. The power supply is in green, so we're very, very close. Huh, but yet still very, very far away, as close as we are. But I mean, we made a ton of progress. We figured out what devices I actually have. We slotted in the SATA ports, which are going to be great. We powered up the machine with no error codes. So all we're doing is trying to get to the BIOS or get to a console line, something like that. So the other thing I can try is I'm going to power off the machine again, and then I'll power it back on, and I'll just spam F2 and F8 on my keyboard, and I might be able to get to the BIOS if I do that. And I'll spam the exit key as well. I'll just spam a bunch of keys on my keyboard as it powers up back up. All right, the monitor turned on. The monitor's in white still. Turned to black. turn back to white. Spamming on my keyboard. So I don't think my keyboard's getting power because I don't see the caps lock come on. So I'm gonna have to use a different keyboard. That'll probably help. Ugh. All right, yeah. So my keyboards looks like they're not getting power. Uh, okay. Hmm. All right, I'm just trying all of the USB slots to see if one of them happens to power up my keyboard. All right, nothing so far. So there's the problem right there. I think I can't get a signal to my keyboard, and it could be the keyboard itself, but I think more likely it's I must have pulled a cable on the motherboard or something that powers up the USB slots or something like that. Okay, so now I've got one keyboard that is powering up. So the issues were the keyboards. I've just got a bunch of junk keyboards laying around. So all right, and I'll show on the camera what I'm doing here. So I've got the keyboard that works and the junk keyboards that don't over there. I've got it. I know it works because when I hit caps lock, we can see the indicator actually comes on or off. So we know that it's working because of that. We see the monitor is still just blinking. So I don't know what's going on with that. So that's where I'm at is now that I have a keyboard plugged in that's working, I have to get a signal to this monitor. And the monitor works, I think, since it's going in white, like that means that it works. The thing that's not working is it's not getting a signal from the tower. I'm just pushing buttons on it. Hmm. Yeah, okay. So next issue. Sometimes the monitor, sometimes the keyboard works, sometimes it doesn't. It's cycling through working and not working for some reason. And we do have status codes now, but they are in amber. But the status code is 123. Um, it's not in green, it's in amber, but let's check the documentation anyway. So some other failure has occurred. So the monitor might not be plugged into a discrete graphic card. All hard drives and optical cables might not be properly connected to the system board. There might be an error message on the screen. Uh, nope, so don't have that. Screen's not working. My device is just a floppy drive. Yeah, so I think we've definitely got 1, 2, and 3. It's not in green, but it is indicating an issue.
All right, not sure what's going on with this. I do think I need a break. Typically, I'm only good for an hour, and it's been nearly 3 hours working on this. But the good news is we did make quite a bit of progress. We picked out the hardware to use. We got everything. So it's just one final step remaining, and that is getting this up and running. Yeah, so the other thing we can do with it is swap out, we can swap out another card. I do have a graphics card I can harvest from my laptop. That might work as well if we just but um but this video's been going for too long, so I'm gonna stop it here. And when I come back, I'll have harvested that card out of my laptop, and we'll try from there. So thanks for watching, and see you in the next one.